The crystalline spires of the Galactic Institute of Advanced Engineering pierced the violet skies of Centauri Prime, their surfaces refracting the light of 3 suns in a dazzling display of technological superiority. Maya Patel stood at the entrance, her worn leather toolkit hanging heavily at her side, a stark contrast to the quantum computers and neural interfaces her alien classmates carried. The daughter of a Mumbai mechanics shop owner, Maya had earned her place here through a combination of raw talent and stubborn determination. She'd spent her childhood rebuilding everything from vintage motorcycles to solar arrays, learning the art of engineering through calloused hands and practical experience rather than theoretical simulations. Biological entity Maya Patel, you are impeding optimal pedestrian flow patterns. The mechanized voice came from behind her, where a group of Xerxian students, their chrome-plated bodies gleaming in the morning light, waited to enter the building. Maya stepped aside, mumbling an apology, though she doubted the Xerxians' audio processors were calibrated to detect human embarrassment. Inside the Advanced Materials Laboratory, Professor ZYX-427 floated near the ceiling, their gaseous form shifting through shades of academic superiority. The professor's voice resonated through the chamber, a careful modulation designed to be understood by all species present. Today marks the beginning of your final qualification trials. Your performance here will determine whether you are worthy to join the ranks of the galaxy's elite engineers. Maya found her assigned workspace, notably lacking the quantum interface ports her classmates were already connecting to. Immersion student to her left, their crystalline form refracting light in patterns of barely concealed amusement, whispered to their lab partner, "Look at the primitive's workspace. I didn't realize the institute was running a museum of ancient technology." Professor ZYX-427 descended to hover directly in front of Maya. "Ms. Patel, I must verify, you understand that this course requires the design and construction of advanced engineering solutions? While we appreciate Earth's quaint contributions to the field, perhaps the basic engineering program would be more appropriate for your species' current technological level." Maya met the professor's fluctuating gaze steadily. "With respect, Professor, I earned my place here. Judge my work by its results, not by your assumptions about my species." The professor's gaseous form rippled in what might have been surprise or amusement. "Very well. Though I should warn you, tomorrow's challenge will require significantly more sophistication than the internal combustion engines your species seems so proud of." As her classmates interfaced with the lab's quantum systems, Maya pulled out her father's old notebook, actual paper, which caused several nearby students to recoil in horror. She smiled, remembering his words, "Beta, they'll have their fancy toys, but remember, the simplest solution is often the most elegant. And more importantly, it's usually the most reliable." The day's lecture covered quantum field manipulation and its applications in emergency environmental systems. While other students absorbed the information directly through their neural interfaces, Maya took careful notes by hand, her mind already beginning to see connections between these advanced concepts and the basic engineering principles she'd grown up with. A hive-mind cluster of insectoid ZRarcate students formed a living computer network near her, their bodies arranging and rearranging in complex computational patterns. "Observe," one segment of the cluster vibrated, "the human insists on processing information through primitive biological neural pathways. Fascinating, in an anthropological sense." Maya ignored them, focusing instead on sketching out an idea that had begun to form in her mind. The principles of pressure distribution in a quantum field weren't so different from the way her father had taught her to design support structures for buildings in earthquake zones. Sometimes the oldest solutions could be applied to the newest problems, you just had to see the connections. As the day drew to a close, Professor ZYX-427 announced tomorrow's challenge. Each student would need to design and construct an emergency atmospheric stabilizer capable of maintaining optimal conditions for multiple species simultaneously. The professor's form rippled with what might have been anticipation or concern. "Ms. Patel, given your technological limitations, perhaps you would prefer to withdraw?" Maya packed up her toolkit, her mother's voice echoing in her memory, "Your difference is your strength, Beta. Let them underestimate you, it makes proving them wrong all the sweeter. No, Professor, Maya replied, a slight smile playing at her lips. I think I'll manage just fine. The next morning, the Advanced Materials Laboratory hummed with anticipation. Holographic displays flickered to life around each workstation, projecting the challenge parameters in 27 different languages. Maya squinted at the standard Galactic text, her universal translator working overtime to process the technical specifications. Professor ZYX 427's gaseous form expanded to fill the upper portion of the room, their voice resonating at precisely calculated frequencies. Your challenge today will test not just your theoretical knowledge, but your practical ability to create solutions under pressure. You must construct an atmospheric stabilizer capable of maintaining life-supporting conditions for Class A through Class M respiratory systems simultaneously. The professor's form coalesced into a more focused cloud near the central display. The stabilizer must function in environments ranging from vacuum to high-pressure methane atmospheres. It must regulate temperatures from absolute zero to plasma-adjacent conditions. And most critically, it must do all this using only the basic materials provided. A ripple of concern passed through the assembled students. Near Maya, a Mersian crystal form student chimed in distress, their lattice structure vibrating with anxiety. Professor, you cannot mean, without quantum processors? Precisely. The professor's form flickered with what might have been satisfaction. In crisis situations, you cannot always rely on advanced technology. Sometimes, you must work with limited resources. Their gaseous tendrils gestured toward the material synthesizers along the wall. You have access to standard alloys, thermal conductors, pressure regulators, and basic tools. This last part was delivered with a pointed ripple in Maya's direction. The Xerxian twins to Maya's right immediately began interfacing with their workstation's quantum probability calculator. Initial analysis suggests 99.87% probability of project failure without standard quantum stabilization matrices, they announced in perfect synchronization, their chrome surfaces reflecting the anxiety of the room. Maya studied the material options available. While her classmates gravitated toward the most exotic alloys and experimental composites, her eyes were drawn to the simpler options. There, behind the quantum-enhanced metamaterials, she spotted something that made her smile: standard titanium alloy sheets, carbon fiber composites, and what appeared to be basic pressure valves. Mr. ZRR-Kate, Professor ZYX 427 addressed the HiveMind cluster. Please explain why quantum processing is typically considered essential for atmospheric regulation. The insectoid cluster reformed into a rough approximation of an atmospheric stabilizer. The computational requirements for maintaining multiple atmospheric conditions simultaneously exceed the capabilities of non-quantum systems. The probability calculations alone for managing the interaction between different atmospheric requirements would require a different approach entirely, Maya muttered under her breath, already sketching in her notebook. Her father's voice echoed in her memory: nature solved most of these problems long before we invented computers to calculate them. The Mersian student next to her resonated with barely contained derision. The human appears to be drawing with processed tree pulp. How quaint. Perhaps she plans to solve quantum mechanics with stick figures. Maya ignored the comment, her mind racing through possibilities. The challenge wasn't actually about maintaining separate atmospheres, it was about creating stable transitions between them. Her thoughts drifted to the mangrove swamps she'd studied in environmental engineering back on Earth, how they created gradual transitions between salt and fresh water. You have precisely 4 standard hours, Professor ZYX 427 announced. Begin. The laboratory erupted into activity. The Xerxian twins had already started fabricating quantum neural interfaces, their chrome appendages extending into the material synthesizers. The Mersian students formed a crystalline computing matrix, their bodies resonating in harmony as they calculated optimal molecular configurations. The ZRR-Kate HiveMind split into thousands of individual units, each tackling a different aspect of the mathematical models. Maya walked calmly to the material dispensary, picking up basic tools that would have looked at home in her father's workshop. The hive mind briefly paused their calculations to observe her. The human selects primitive implements. Probability of success approaching 0. Professor ZYX-427 hovered nearby, their gaseous form conveying what might have been concern or curiosity. Ms. Patel, while I admire your determination, perhaps you don't fully grasp the complexity of maintaining multiple atmospheric conditions simultaneously. Maya looked up from where she was measuring a sheet of titanium alloy. Actually, Professor, I think everyone else might be overthinking it. Sometimes the most elegant solutions come from understanding basic principles rather than forcing them through quantum calculations. Fascinating, the professor's form rippled. And how exactly do you plan to regulate multiple atmospheric conditions without quantum processing? Maya held up her sketch. By not trying to control everything at once. Nature figured out how to handle atmospheric transitions long before we invented quantum computers. I'm just going to borrow a few ideas that have already been proven to work. The professor's form condensed slightly, a sign of intense interest. You propose to solve a quantum-level engineering challenge using biological principles. Not exactly, Maya said, already beginning to cut the titanium sheets. I'm proposing to solve it using engineering principles that we've observed working in biological systems. There's a difference. Around her, the laboratory continued its frantic pace. 2 hours into the challenge, the first signs of trouble began to appear. The Xerxian twins' quantum matrix kept destabilizing when they attempted to bridge the gap between methane and oxygen-based atmospheres. The Mersion crystal array, while theoretically perfect, consumed so much energy that it would have drained a small city's power supply in minutes. The ZRarcate hive mind's calculations had reached such complexity that several members had to withdraw from the collective to prevent computational overflow. Maya, meanwhile, had constructed what appeared to be a series of concentric spheres, each connected by what looked suspiciously like mechanical valves. The outer layer was nearly complete, its surface a patchwork of titanium alloy and carbon fiber composite that caught the light in a distinctly non-quantum way. Ms. Patel, Professor ZYX-427's voice carried a note of genuine curiosity now, would you care to explain your approach? Maya wiped sweat from her forehead, leaving a smudge of machine oil that made several nearby students recoil in horror. It's based on the principle of gradual transition zones, Professor. Instead of trying to maintain multiple atmospheric conditions simultaneously through quantum manipulation, I'm creating a series of discrete chambers that progressively shift from one condition to another. The professor's gaseous form swirled in what might have been confusion. But without quantum processing, how can you possibly calculate the optimal transition gradients? I don't need to, Maya replied, adjusting a particularly stubborn valve. Nature already did that calculation for us. Think about Earth's atmosphere, it doesn't maintain a uniform condition throughout. It has layers, each with its own characteristics, but with gradual transitions between them. The ZRarcate hive mind had partially reformed to observe her work. The human's design appears to utilize mechanical principles rather than quantum mechanics. Our calculations suggest this should not be possible. That's because you're calculating it as a quantum problem, Maya explained, her hands never stopping their work. But it's really a fluid dynamics problem. Each chamber acts as a buffer zone, creating a gradual transition that's maintained through simple mechanical principles rather than constant computational adjustments. A small crowd had gathered around her workstation. The Mersion student who had mocked her earlier now chimed with reluctant interest. But how will you handle the energy requirements? Our crystalline matrix requires tremendous power to maintain quantum coherence across multiple atmospheric conditions. Maya grinned, pointing to a series of thermal exchange vents integrated into her design. It's actually nearly passive. The temperature and pressure differentials between chambers do most of the work for us. We just need to guide the natural flow of energy rather than forcing it. Professor ZYX-427 hovered closer, their form condensing with concentration. You're suggesting that instead of using quantum technology to force multiple atmospheres to coexist, you're creating a system that works with the natural tendencies of different atmospheric conditions rather than against them, Maya finished. Each chamber serves as a stepping stone between environments. The pressure gradients and temperature differentials actually help maintain the system's stability rather than fighting against it. The Xerxian twins had paused their quantum calculations to analyze her design. This approach appears to violate several principles of advanced atmospheric engineering, they announced in unison. Only if you assume quantum processing is the only way to solve the problem, Maya replied, fitting the final valve into place. Sometimes the most advanced solution isn't the most practical one. Look at evolution, nature's been solving complex engineering problems for billions of years without a single quantum computer. As if to punctuate her point, a sudden burst of energy from the Mersion crystal array sent sparkles of quantum disruption across the laboratory. Several students ducked as their delicate quantum matrices flickered and destabilized. Maya's mechanical system, however, continued functioning smoothly, its concentric chambers maintaining their gradual transitions without any computational assistance. The ZRarcade hive mind buzzed with increasing agitation. This defies our mathematical models. The system should not be able to maintain stability without constant quantum adjustment. That's the beauty of it, Maya explained, making a final adjustment to the thermal exchange system. It's stable precisely because it's not trying to maintain perfect control. It's designed to flex and adapt within acceptable parameters, just like natural systems do. Professor ZYX-427's form had stopped rippling entirely, a sign of intense focus. Ms. Patel, are you suggesting that by deliberately avoiding the use of advanced technology, you've created a more robust solution? Not exactly, Professor, Maya said, stepping back to observe her completed work. I'm suggesting that by understanding the fundamental principles at work, we can sometimes find simpler solutions that are just as effective as more complex ones. Advanced technology is incredible, but sometimes we get so caught up in what we can do with it that we forget to ask if we should. The laboratory had grown quiet, all eyes and sensory organs fixed on Maya's creation. It wasn't beautiful in the conventional sense, no quantum shimmer, no crystalline perfection, no mathematical elegance. Instead, it had the solid, practical appeal of something built to last. As the final hour of the challenge approached, Maya's device continued its steady operation while her classmates struggled with increasingly unstable quantum matrices and power consumption issues. The Xerxian twins had resorted to running probability calculations on her design, their chrome surfaces reflecting confusion as each analysis suggested that her primitive solution might actually work better than their quantum-based approach. Sometimes, Maya murmured, remembering her father's workshop, the best technology isn't the newest, it's the most reliable. The final hour of testing had barely begun when the laboratory's main power grid fluctuated. It was a tiny disruption, lasting less than a microsecond, but its effects cascaded through the quantum-based projects like a wave through a pond. The Xerxian twins' matrix collapsed instantly, its carefully maintained quantum states dissolving into chaos. The Mersion crystal array shattered into 1,000 glittering shards, its delicate lattice unable to maintain coherence without constant power. Emergency protocols initiated, the laboratory's AI announced, its voice eerily calm. Detecting multiple quantum field destabilizations. Warning, atmospheric containment systems compromised. Professor ZYX-427's gaseous form contracted in alarm. Everyone remain calm. The laboratory's backup systems will, their voice cut off as the secondary power grid failed, plunging the room into darkness broken only by the emergency lights and the sparking remains of damaged quantum projects. Professor. The ZRarcade hive mind's collective voice carried an edge of panic. Our atmospheric processing units are failing. Without power to maintain quantum coherence, the atmospheric barriers between species will collapse. The gravity of the situation hit everyone at once. The laboratory contained 27 students from 15 different species, each requiring specific atmospheric conditions to survive. The quantum-based life support systems that usually maintained their individual environmental bubbles were failing one by one. Maya's voice cut through the growing chaos. "Professor, my stabilizer is still functioning. It doesn't rely on the power grid, the mechanical systems are self-sustaining once initialized." The professor's form swirled toward her station, where her concentric sphere design continued its steady operation, unaffected by the power failure. "Ms. Patel, are you suggesting it can handle multiple atmospheric conditions simultaneously?" Maya said, already moving to adjust the outer chamber. "The capacity isn't as high as the quantum systems, but it should be able to maintain survivable conditions for everyone until power is restored." "Impossible," the Xerxian twins declared, their chrome surfaces reflecting the emergency lights. "A mechanical system cannot possibly maintain the precise atmospheric conditions required for." "It doesn't need to be perfect," Maya interrupted, her hands moving quickly over the controls. "It just needs to keep everyone alive. Professor, we need to get everyone inside before the main atmospheric barriers fail completely." Professor ZYX-427 hesitated for only a moment before their form rippled with decision. "All students, proceed to Ms. Patel's station immediately. Maintain order and follow her instructions." Maya's mind raced as she calculated capacity. The outer chamber would work for oxygen breathers, the middle layers could handle the methane-based life forms, and the core could maintain the high-pressure environment needed for the crystalline species. It wouldn't be comfortable, but it would work. "Mersion students first," she directed, opening the core chamber. "Your crystalline structure is most vulnerable to atmospheric pressure changes." The crystal-based students chimed in harmony as they moved into position, their forms stabilizing as they entered the high-pressure environment. "Zerarchate Collective next," Maya continued, adjusting the middle chamber's methane mix. "Spread your consciousness across fewer units to conserve space. Xerxians, your chrome shells can handle the transition, but move quickly." One by one, the students entered her stabilizer. Maya made constant adjustments to the mechanical valves, finding the balance between different atmospheric needs. It wasn't the perfect, quantum-calculated environment they were used to, but it was keeping them alive. "Fascinating," Professor ZYX-427 observed as they compressed their gaseous form to enter through a specialized valve. "The system is actually becoming more stable with use. The interactions between different atmospheric requirements are creating self-reinforcing patterns." Maya nodded, sweat beading on her forehead as she fine-tuned the pressure differentials. "That's the advantage of working with natural principles instead of against them. The system adapts and finds its own balance." The laboratory's main atmospheric containment was failing rapidly now, but every student had made it inside Maya's stabilizer. The concentric chambers hummed with activity, each layer maintaining its distinct environment while allowing for controlled interaction at the boundaries. "Power restoration estimated in 30 minutes, the laboratory AI announced to the now crowded stabilizer. Several students shifted uncomfortably in the unfamiliar conditions, but Maya's design held steady. "Notice," Professor ZYX-427's voice carried a note of wonder, "how the system compensates for our movements automatically. No quantum calculations, no power input, just mechanical principles working in harmony." The Xerxian twins, their chrome surfaces slightly dulled by the methane atmosphere, spoke in their characteristic unison. "We are recalculating our assessment of primitive engineering principles." Maya managed a smile as she monitored the pressure gauges. "Sometimes the old solutions are the best ones. Humans learned a long time ago that the most sophisticated answer isn't always the right one." Through the transparent sections of the outer chamber, they could see the chaos of the laboratory, quantum matrices dissolving, crystalline structures shattering, holographic displays flickering into nothingness. But within Maya's primitive design, 15 different species continued to breathe, their various atmospheric needs met by nothing more complex than carefully designed mechanical systems and the principles of fluid dynamics. Perhaps, the professor's form rippled thoughtfully, we have become too reliant on solving every problem with quantum computing. We've forgotten that engineering excellence isn't about using the most advanced solution possible. It's about using the right solution for the problem at hand, Maya finished, her father's words echoing in her memory as she watched her classmates breathe safely within her creation. A week after the laboratory incident, Maya stood before the Galactic Institute's Engineering Council, her father's worn notebook clutched in her hands. The grand chamber, with its quantum crystalline architecture and hovering platforms, seemed designed to make presenters feel small. But Maya stood tall, surrounded by the evidence of her success. Her atmospheric stabilizer had been moved to the center of the chamber, its concentric spheres now a testament to the power of practical engineering. Around it stood holographic displays showing detailed analyses of its performance during the crisis, each measurement confirming what they had all witnessed firsthand. Ms. Patel, began Arch-Engineer Vex 9, their energy form pulsing with formal authority, your actions during the laboratory crisis saved the lives of 27 students and 1 professor. However, we are not here merely to commend your quick thinking. We are here to understand how a design that violates virtually every principle of modern atmospheric engineering proved more reliable than our most advanced systems. Maya took a deep breath, remembering her mother's words about standing her ground. With respect, Arch-Engineer, my design doesn't violate engineering principles, it simply approaches them from a different perspective. One that prioritizes reliability over complexity. Professor ZYX, for 27, now fully recovered, contributed from their floating platform. Indeed. Ms. Patel's design demonstrated remarkable stability during the power failure. While our quantum-based systems collapsed, her mechanical solution continued functioning without external power input. The Xerxian twins, who had requested to attend the hearing, added their synchronized analysis. Our subsequent studies indicate that the design's efficiency actually increases under stress. The mathematical elegance was there all along, we simply failed to recognize it because it didn't match our preconceptions. Maya stepped forward, activating her own holographic display. Engineering isn't just about creating the most advanced solution possible. It's about creating the most appropriate solution for the problem at hand. Sometimes that means using quantum computing and artificial intelligence. But sometimes it means looking back at principles that have been proven to work over millions of years. She gestured to her stabilizer. Every aspect of this design is based on natural systems that Earth's evolution has refined over countless generations. The pressure gradients mimic our atmosphere's layers. The thermal exchange system is modeled after ocean currents. The adaptive chambers work like the gradual transitions in mangrove swamps between salt and fresh water. The council members stirred, their various forms showing signs of intense interest. Arch-Engineer Vex 9 spoke again, you are suggesting that by studying what you call primitive systems, we might find solutions that our advanced technology has overlooked? Not primitive, Maya corrected gently. Proven. Every principle used in my design has been tested by nature over billions of years. By understanding these fundamental mechanisms, we can often create solutions that are more robust and reliable than ones that rely on constant computational adjustment. The ZRarcade HiveMind representative buzzed thoughtfully. Our collective has analyzed the incident data. The human's design succeeded not despite its mechanical nature, but because of it. In crisis situations, simplicity equals survivability. Precisely, Maya agreed. Advanced technology is incredible, and it's vital for pushing the boundaries of what's possible. But sometimes, in our rush to use the most sophisticated solution available, we forget to ask whether it's actually the best solution for the problem at hand. Professor ZYX 427's form rippled with what might have been pride. Ms. Patel has demonstrated something our institute had forgotten, that engineering excellence isn't about the complexity of the solution, but about its effectiveness. Arch-Engineer Vex 9's energy form pulsed with decision. The council has reached a consensus. Ms. Patel, your design will be incorporated into our emergency systems across all Institute facilities. Furthermore, we are establishing a new research division focused on what we are calling natural engineering principles. They paused, their form brightening. And we would like you to lead it. Maya blinked in surprise. Me? But I'm still a student. A student who just revolutionized our approach to environmental engineering, Professor ZYX, 427 interjected. Sometimes fresh perspectives come from those who haven't yet learned to accept limitations as absolute. Maya looked down at her father's notebook, thinking of all the practical wisdom contained in its worn pages. I would be honored, but on one condition. The council stirred with curiosity as she continued, this shouldn't be just about applying Earth's natural principles. Every inhabited world in the galaxy has developed its own elegant solutions to engineering challenges. If we study them all, learn from each planet's evolutionary innovations, think how many new solutions we might discover. Arch-Engineer Vex 9's form glowed with approval. An excellent suggestion. Perhaps it is time for the Galactic Institute to remember that wisdom can be found in understanding the fundamental principles of the universe, not just in our ability to manipulate them through technology. As Maya left the council chamber that evening, she sent a message to her father back on Earth. Dad, remember how you always said the simplest solution is usually the best one? Well, it turns out that's true even on a galactic scale. And guess what? They're finally ready to listen.